Good day, folks. Welcome to my YouTube channel. If you're new here, welcome. Please don't forget to subscribe. Watch my videos till the end. Returning subscribers, welcome back. I appreciate your support. Like my video, watch the ads, watch the video till the end. Now, guys, this is the Eastern Cape question paper. It's June 2024. We're going to look at the paper 2, which is the rates of reaction. Question 5. Let's cut the chase. A group of learners used the reaction between magnesium carbonate and an excess hydrochloric acid to investigate some of the factors that affects the reaction rate. The balance equation for the reaction is it's magnesium carbonate reacts with an hydrochloric acid, magnesium chloride, water, carbon dioxide. That is what is formed. If you can see here, we have a conical flask with a magnesium carbonate and acid there, and then the gas, it goes there and measured there in that syringe there. So that carbon dioxide there. Right, guys, it says the table summarized for the reaction conditions. So this reaction has been repeated 3 times. Now, if you look at experiment 1, the concentration is the same. So the concentration here in this experiment has been a control variable. Now, if you look at the state of division, it has been different. In experiment 1 is the powder, and in experiment 2 is the powder, and in experiment 3 is the lump, which is the state of division is different there. And let's look at the temperature. The temperature there, if you look at the temperatures are different there. So also temperature has been changed there. All right. Now 5.1, it says define the rate. Okay, guys, according to exam guideline, it says the rate is a change in concentration or product per unit time. Now it says write down the independent variable for the comparison between experiment 1 and experiment 2. So the comparison between the two experiments 1 and 2, if you look at 1 and 2, the difference there is the what? It's the temperature, because their concentration is controlled, their state of division is controlled, and it's the temperature. So the independent there is the what? Temperature. Right, that's the answer there. Right, let's look at the, let me use the blue one. Let's look at 5.3. It says experiment 2 and 3 is now compared. Let's look at 2 and 3. 2 and 3. What's the difference there? The concentration of HCl is the same, state of division are different, temperature is different. So what is different there? It's the what? That's the state of division, right? Now it says which experiment 2 or 3 will have the highest rate of reaction. So what will have the highest rate of reaction between the two is the one that has a greater surface area, which is its experiment 2. It's a powder. So the answer there, it's what? It's experiment 2. Now 5.3.2, it says explain your answer. Explain the answer from this by referring to the collision theory. It's 3 marks. That means it's going to be 3 points. You're going to talk about the experiment 3. Why is it experiment 2? Why is it higher? Which is it has a higher surface area. So point number 1, you'll say larger surface area, because it has a larger surface area. That's the reason. Experiment 2, it has a larger surface area. Or you can say more particles are exposed, right? More particles are exposed today, right? Or you can say no, the next point, now you'll say more. The second point, remember it's 3 marks, right? You say more particles with correct orientation right? And the last point, you will talk about the more effective. If there's a larger surface area, there will be more effective collision per unit time. Remember, you can't just say more effective collision, there must be per unit time there. 5.4. Let's look at 5.4. 5.4, it says learners measured the rate of carbon, the rate at which the carbon dioxide was produced in experiment 2, and found that 0.2 gram per minute, which is, this is the what? This is the rate. This is the rate of the how the carbon dioxide was produced, and then it says it took 10,44 minutes to measure the time taken for the reaction to reach completion. So this reaction, it lasted for 10.44. That's the time, right? Now they say calculate the mass of calcium carbonate was used. So from this reaction, we want the mass of this that reacted to give us this. So what are we given now? We're given the rate of the carbon dioxide was produced. That can help us to get this amount that was used. Remember, this one is a limiting. It has been used up completely. So this rate is going to help us to get this amount that has been used up. So what we're going to do there, in 5.4.1, we're going to make use of the rate. Guys, there will be no conversion there. No conversion there. So our rate is gonna be change in mass over change in time, which is the mass final minus the mass initial divided by the T final minus the T initial. And then we substituted the rate. The rate is 0.25 gram per minute. 0.25 gram per minute. So remember that we're looking for the final volume. The initial volume was 0, right? At the T0, the initial volume was 0. So this volume that we are looking for, it's the final, not volume, sorry, the final mass. Initially, there was no mass at T0, so we are looking for the final mass. Guys, I'm sorry about the dogs that are barking outside. So it's going to be 0, the initial mass, and the T final, it's that 10.44 minutes minus what? 0. And then we'll cross multiply it there. So the mass final, the answer there, if you say 0.25 times 0.25 times 10.44, we're going to get the 2.61 gram, which is, this is the mass of what? Of carbon dioxide, right? This is going to help us. This is step number 1. Let's say this is step number 1. And then step number 2, what are we going to do now? Remember, we got the mass of this. We got the mass of this. We're looking for that. So we're going to change that mass into number of moles, and then we do the mole ratio between the two, right? You can see the ratio is 1:1. So we're going to convert the mass into number of moles. So we're going to say number of moles of carbon dioxide is equal to mass over molar mass. So the mass is 2.61 divided by the calcium carbonate, it's 44, its molar mass. And then the answer there, it will be 5.93 times 10 to the power negative 2 what? Mole, right? So step number 3, what we're going to do there, step number 3, we're going to do a mole ratio. Mole ratio. So to get the amount of magnesium carbonate reacted. So since the ratio there is 1:1, the ratio is 1:1. So we're gonna say the number of moles of what we're looking for, which is the magnesium carbonate. We want the number of moles used is equal to the number of moles of carbon dioxide formed. That's the carbon dioxide formed or produced, which is the answer is going to be 5.93 times 10 to the power negative 2 mole. Since the ratio is 1:1, they are equal, right? And then step number 4, having that mass, now we have the mass of the magnesium carbonate, right? So we're going to change, in step number 4, we're going to change the number of moles. We have the number of moles, we're going to change into mass, because the question, it wanted the mass. So we're going to say number of moles is equal to mass over molar mass. So our number of moles is 5.93 times 10 to the power negative 2, and the mass is the one that we're looking for. And the molar mass, guys, the molar mass of the magnesium carbonate is 84. How is it 84? It's 24 plus 12 plus 16 times 3 is equal to 84, right? So it's going to be 84, and then we multiply. So the mass of magnesium carbonate now used, magnesium carbonate used is going to be 4.98 grams. That's the mass that has been used. Guys, I hope this makes sense. Now let's look at 5.4.2. Calculate the molar gas volume, which is they want the VM. If the carbon dioxide is 1.47, which is, this is V, DM3 was released. So in order to get the VM, we must have a V and the number of moles. We already have the number of moles here of the carbon dioxide, which is that. So it's 5.93. So this is 5.4.1. So we are looking for VM. We have the V, which is 1.47. It's 1.47 at DM3. And then we have the number of moles of carbon dioxide, which is 5.93 times 10 to the power negative 2 mole, right? So we're going to that formula. Number of moles is equal to V over Vm, right? So the number of moles is 5.93 times 10 to the power negative 2, and the V we have, it's 1.47. We divide by Vm. That's the one we're looking for, and then we cross multiply. There. So it's going to be Vm is equal to 1.47 divided by 5.93 times 10 to the power negative 2. And then the answer there, it will be 24.79 DM3. That's the molar gas volume, right? That's the molar gas volume there. I hope it makes sense. Now, let's go to the next question, which is 5.5. It says the graph below, it's a Maxwell-Boltzmann distribution curve for the carbon dioxide produced in experiment 1. So these are the particles of the carbon dioxides that are produced, and this is the kinetic energy, right? Now it says redraw the graph. I'm not going to redraw it, guys. I'm going to pretend this is what I've redrawn there, right? I'm gonna draw it here. Now it says, and label it A. Redraw the graph in answer book, clearly label it A. So this is my A, right? Now they say on the same set of axes, sketch the curve that will be obtained for carbon dioxide if the mass of calcium carbonate increased. Remember, the calcium carbonate is the what? Is the limiting. So if the limiting has been changed, that the carbon dioxide form will change, right? So it has increased from what it was. So our graph will have more number of particles, right? So if the mass, from this formula that says mass over molar mass, so if the mass has increased, the number of particles increases. So our graph is going to be like that, like the concentration graph. The concentration graph, yeah, it moves up. The peak is high, it moves up. So they said we must label the curve as what? As B. So our graph is going to be like that. The concentration graph is like that. So if the mass increases, the number of particles increases, which is the concentration increases, right? If the number of particles, which is this, increases, the concentration increases. So it's like the concentration graph. I hope that makes sense, guys. Cheers. Bye.